Here we're given a polar point, 12 comma pi thirds, already plotted. And what we're asked to do is to find 4 other polar representations, other polar coordinates that land on that exact same spot. That's a big difference between polar coordinates and rectangular coordinates. There's more than one representation for every polar point. So here in part A, I'm asked to let r be positive. Well, r is either 12 or minus 12, so I get half the problem correct for free. Now I just need to find an angle that's less than 0 that ends up at this same spot, so now I know I'm just rotating this way. Well, that's pi over 3, so I just need to imagine what this other rotation is. Well, this would be minus 2 pi if I go all the way around, so I need to add pi thirds back to that minus 2 pi, so that's minus 6 pi over 3 plus pi thirds. I get minus 5 pi thirds. So we've done part A. Part B, I'm asked for a positive angle, but an r that is less than 0. Well, what I like to think about is if I'm going to have r to be less than 0, number one, I know that's a minus 12. To end up at that spot, what I need is a point that would be reflected through the pole back to that spot. So this is the angle I need. So I need to imagine what it would take to rotate down to there, because let's see. That point's really the one. If I had 12 comma this angle, minus 12 comma that angle would rotate back up there. So I need to think about what angle this is. Well, that's 1 pi third, 2 pi thirds, 3 pi thirds. That's positive 4 pi over 3. In part C, I have r is less than 0 again, so that minus 12. And this time my angle is supposed to be less than 0. So now I'm rotating this way, but exactly to that spot right there, and that's minus 2 pi thirds. Finally, in part D, I'm asked for a positive r and another positive theta, but this one bigger than 2 pi. Well, if I'm here at pi thirds, and I still want to rotate positively and get back there, well, I'm just going to add 2 pi to it, so I get 7 pi thirds. And there I found multiple representations, and now I can imagine that if I just add and subtract 2 pi's to any of those angles, I end up with infinitely many polar representations for that point.